In this video, we will learn how to extract data from a web server or directly from a website. R is a versatile platform for importing data from different sources of web like web pages, web API, information portals, etc., which happen to be in a semi-structured and unstructured format rather than traditional structured data formats. The common types and their solutions for web data formats are: for HTML documents, web scraping, methods like readLines and rcurl; for CSV, text and XLS, zip from data portals using file, URL, unz function; and for XML and JSON formats using XML and jsonlite. Before we start using these functions, first we have to create a connection to the website or the web server to download the data to use the functions on it. First one is creating our connection to a web file. For that, we will use a simple function called file or a URL, which is a function to create open and close connections to a web file. The parameters of both file and a URL are similar, except file is specially made for downloading a file from the web, and another unz function for zip file format. Let's see each of them with an example. To download the file and the URL, simply type the file path, either local or web, or the URL address inside their respective functions. Done. Then read the file from the connection, that is the R object made by the file and the URL function, using our regular R-based functions like read.csv, read.table, readLines, etc. We can also use the file link in the R-based functions rather than saving it in an R object. XML is another web file format, also known as extensive markup language, that defines a set of documents in a format that is both human readable and machine readable, meaning that the structure of the data is embedded with the data itself. Thus, when the XML data is loaded, there is no need to format the data structure to store and use the data. I have put an example of how XML data looks like. An XML data is identified by an element defined by a beginning and an ending tag. The first one is the root element. Let me show you an example of how can we read the XML data. XML includes functions that are used to parse an XML document. 3 common steps to read the XML data. First, load the XML document into an R object. Use XML3 parser function to parse the XML file. Then use XML root function to identify the root element. Then finally extract the values of the XML with XMLS apply. Note one thing while installing the XML package. Select N, that is no, when asked for do you want to install from sources, the packages needs compilation. Now load the XML document in an R object, then parse the XML document in the R object using XML3 parse. Third step is to identify the top node using XML root. Now extract the values using XMLS apply. Now you can view the data using our regular view function. Our next popular web data format is a JavaScript object notification file, in short .json. Store data structures. JSON store data structures and objects in a format originally based on a subset of JavaScript. It is primarily used for transmitting data between web applications and a web server, and is becoming very popular as alternative to XML. Here is the example of JSON file format. JSON data format is like a bit of programming kind of language, but we only need to know the formats and the syntax to guide ourselves to set the parameters of the read function. Now, to handle the JSON file format, one can leverage the simply yet rich features of JSonlite package for R. JSonlite converts the R objects to and from JSON using from JSON and to JSON function. You can go through the parameters to customize the loading of the JSON data. Let me give you an example on how to read a JSON file. First, again we have to install JSonlite package to read the JSON formatted file. Then define the JSON file in the form JSON function. Done. Complete. To view the data, use the view function. Easy, isn't it? Web API. To understand the web API, first let's understand what is Application Programming Interface. API in short. API is an interface of application data or other services that allows programmers to access without being explicitly visiting the application. So a web API is an API over the web which can be accessed using the protocols like HTTP. For example, Twitter's API that provides programmatic access to read and write data using which we can integrate Twitter's capabilities into our application. The tools for accessing the web APIs from R, ACS are Google Analytics, Amazon Web Service, AWS S3, etc. for vendor-specific service, HTTR for making request, JSONlite XML2 to parse the response. Steps involved for applying web API in R: first, follow the vendor-based API documentation, then requires a developer's account for API authentication. Insert the API authentication credentials and the API key into our web API's packages and start receiving the data. However, there is another easy way of gathering web data is web scraping. So let's see what is web scraping. We often do come across tables on a website in an HTML format, and the method of extracting that data is often termed as web scraping. It is also popularly known as screen scraping, web harvesting, web data extraction. Two common methods used for web scraping in R includes readLines, XML, rcurl, rvest, etc. We have already discussed the XML package facilitates working with XML data. So let's perform an example where we'll use the readHTMLTable from XML package to read a table from the website. But before that, let's get familiar with the parameters of the readHTMLTable function. We have doc, that is the HTML document is either a file or a URL. Then header, call classes, trim, a logical value indicating whether to remove leading and trailing white spaces from the contained cells. elfun is function which, if specified, is called when converting each cell as the data frame, a logical value indicating whether to turn the resulting tables into a data frame format or leave them as matrices, which is for choosing the table number, skip rows to skip the rows of the tables. Now load the XML package using library, then save the URL with any R object name. Type the readHTMLTable function with the R object name, then header is equal to true, which is equal to refers which table, for example table 2. Done. You can also try the same for the second table using which is equal to 3. By default, it will take all the table variables as factors, else character if string as factors is equal to false. Now to overcome this issue, we can individually declare the table variable types using column classes, saving the list of column classes according to its position in an R object. You might be wondering what is formatted number data class. This formatted number class tells the R object the numbers have comma with it. Execute the same line of code with column classes is equal to the R object where we have saved the list of classes according to their position. Done. Type str data to verify the changes. Now for basic web scraping tasks, we can also use the readLines and read.csv functions. However, these functions allow simple access to web page source data on a non-secure servers, that is HTTP. For example, read.csv, then the file URL. Then grab the required line starting with em tag using grab function. Using grep function, delete the unwanted characters, that is the em tag and extra spaces and the lines using gsub. Done. Then view the data using a regular view function. There's another package to handle HTTP features such as HTTPS encryption access. We can use the rcurl or the rvest package, and we will use the getURL function from the rcurl package to load the secure HTTPS site. After the web data has been loaded by getURL, we will use HTML3parse function to restructure and parse the data. Once the data is restructured and parsed, we can follow any steps from the previous slides to filter the required data. Next, we will learn how to manipulate data using R-based functions.